Welcome to the Math Practice Standards webinar series. This webinar will provide you information on the sixth mathematical practice, Attend to Precision. We'll start by looking at it in its entirety, then we will unpack it piece by piece. Mathematically proficient students try to communicate precisely to others. They try to use clear definitions in discussion with others and in their own reasoning. They state the meanings of the symbols they choose, including using the equal sign consistently and appropriately. They are careful about specifying units of measure, labeling axes to clarify the correspondence with quantities in a problem. They calculate accurately and efficiently, express numerical answers with a degree of precision appropriate for the problem context. And in the elementary grades, students give carefully formulated explanations to each other. By the time they reach high school, they have learned to examine claims and make explicit use of definitions. As you can see, Math Practice 6 covers several habits that students should be proficient in. Let's break down each section so we can fully understand each of these proficiencies. The first section of the math practice states that definitions are important. Students need to know those domain-specific words in mathematics. There is clear communication using the vocabulary. Mathematically proficient students speak and others understand what they're talking about because they are able to use precise vocabulary. And lastly, the writers felt it was important that students understand the symbols that are used in mathematics and, most importantly, the meaning of the equal sign. This practice also states that proficient students use units correctly. They understand that accuracy and efficiency are both important, so being correct is important as well as speed in finding a solution. Students know when to estimate and be specific. They also recognize appropriate responses in given context. In the elementary grades, students should do a lot of talking to one another about what they do in math. This develops the proficiency in the language skills needed for explaining their thinking and for using precise language. Attending to precision should be nurtured by the teacher. The key is that teachers need to embed time into their plans for students to share. This is one way they discover that others may have a different approach to solving the same problem. By high school, students have upped their game. They can communicate their work and can dissect the work of others. Again, definitions are mentioned. Students must be able to work in a way that shows true understanding of the meaning of mathematics. So now that you have a clear understanding of what Math Practice 6 entails, let's move on to the implementation of this practice in the classroom. This will involve the necessary planning needed for authentic tasks and problems to be incorporated in the lesson design that requires students to share by using precise language. Attend to precision is really about raising the expectations of the students. It's about not allowing for lazy answers. When it becomes the nature of the teacher, it will naturally become the nature of the student. But bad habits last long. So it's imperative that these habits of mind are established at a young age and reinforced throughout the years. In a classroom that stresses precision, you see word walls. Problems are labeled with units and numbers have context. 3 bears, not just 3. Both students and teachers naturally use academic vocabulary. It's all too often that I have seen students not know what a sum or product is, but they sure can tell you what the answer is. If precision is enforced, this would never occur. Planning for the math practices is looking at the actual student experiences that will occur as you teach the concepts. It's about how the students will be learning the concept. What will it look like in the classroom? Attending to precision should be a habit of mind for the teacher first. Always write units beside your examples. Refer to the add-ins and the sums and the differences and the factors and the products. It's not the top number, it's the numerator. It's not the difference in the y values, it's the horizontal change. And it's not FOIL, it's the distributive property. The pedagogy of attend to precision should be prevalent in all K-12 mathematics. So how do we know that our students are developing the habits of mind that call for precision? We pose questions to the students, to ourselves, and eventually expect our students to pose these types of questions to themselves naturally. As you design your student experiences, you should be constantly asking yourself if you are doing what it takes to create the essential habits of mind. Questions might be, did I select engaging problems and tasks? Are the tasks engaging? Do the questions lend themselves to answers that use units or specific academic vocabulary? Is estimation useful, or will it deviate from the precision expected? Here are some additional questions to consider as you plan student tasks and experiences in your math classroom. Do the activities and discussions in my classroom focus on students thinking, expecting grade-level math vocabulary? Do I use precise language when communicating with others during instruction? Do I support my students in understanding math vocabulary? Do I provide opportunities for students to be precise? As we get better at asking ourselves questions during planning, we need to train our students to ask themselves questions too. Training should begin at a very young age and should create lifelong habits. As teachers, we should ask the students these questions as they are engaged in the tasks, but the emphasis is on the fact that we want them to help develop the habit of asking these questions to themselves. Do I understand the vocabulary associated with this problem? Did I use the proper symbols? Did I use context labels? Do I understand the values in the problem? Did I use units of measure? Are my calculations accurate? Many teachers create anchor charts to help students remember these questions. Also, a word wall or a vocabulary notebook can also be a good resource. Let's get more specific about the types of tasks that it takes to provide the desired habits of mind for Math Practice 6, Attend to Precision. Mathematically proficient students try to communicate precisely to others. They are careful about specifying units of measure. This problem demands special attention to the units. While playing baseball, Kyle has to run from first base to second base 4 times. About how many inches does Kyle have to run? You can see that students will have to do some research to find out the length from one base to the next. Because of the use of the internet, this problem becomes far more rigorous for students and poses an authentic question for them to solve. Curriculum and teaching must be meticulous in the use of the mathematical vocabulary and symbols. For example, when students first see the equal sign, it may be used in equations like 5 equals 3 plus 2, or in context like 9 plus blank equals 8 plus 2. In each case, making clear that it signals the equality of expressions and is not merely heralding the arrival of an answer. This task, although it may seem simplistic, is very telling. If students understand the equal sign, they will be able to solve for the missing value. 4.5 equals 2 and what? Fraction. Tasks like these demand the depth of knowledge of the concept of equality. Here's another task. Mrs. Francis drew this fraction bar on the board. Then she asked her students what fraction it represents. Emily said that the picture represents 2/6. Raj says that the picture represents 2/3. Because Raj believes that 3 squares make a whole, so the 2 shaded squares represent 2 out of 3, or 2/3. Sherry said that the picture represents 2. To Sherry, each square represents 1 whole. An argument can be made for all of the solutions. Students are faced with elements of ambiguity in deciding what encompasses the whole. The whole in turn impacts the representation of a specific fraction. Students learn to appreciate, understand, and use mathematical vocabulary more precisely in interpreting and describing the whole and its fractional parts. Initial attention to precision would have produced the results the teacher intended. This particular task supports the demonstration of Mathematical Practice Standard 6. Students evaluate 6 numerical expressions that contain the same integers and operations, but differ in the placement of parentheses. It is essential that students attend to the placement of the parentheses to compute these expressions accurately. During this exercise, students experience first how the value of the expression is dependent upon parentheses placement, and as a result, they learn to appreciate, understand, and use symbols more precisely. Mathematical Practice 2 gives us language that shows students the relationship between the word problem, quantitative, and the algebraic equation, abstract. Most standard word problems are about quantities, asking how many animals, how much money, how many degrees, The possibilities are endless. This task focuses on understanding not only Math Practice 2, but Math Practice 6, attending to precision, since students will see that although being precise, the results can still appear different for different students. Write an expression that it records the calculations described below, but do not evaluate. Add 2 and 4 and multiply the sum by 3. Next, add 5 to that product and then double the result. So I want you to take note. Although there are 6 different results to this task, all 6 are correct. It's that attending to precision, that correct vocabulary. This task demonstrates that without precision, many different expressions could be created. Ocean water freezes at -2.5 degrees Celsius. Fresh water freezes at 0 degrees Celsius. Antifreeze, a liquid used in the radiators of cars, freezes at -64 degrees Celsius. Imagine that the temperature has dropped to the freezing point for ocean water. How many degrees more must the temperature drop for the antifreeze to turn solid? This task is appropriate for assessing students' understanding of differences of signed numbers. Because the task asks how many degrees the temperature drops, it is correct to say that the temperature drops 61.5 degrees. However, some might think that the answer should be that the temperature is changing -61.5 degrees. Having students write the answer in sentence form will allow teachers to interpret their response in a way that a purely numerical response would not be given. A more precise task description would have resulted in the intended expression. You now have a clear understanding of how to implement and create tasks that support Math Practice 6. Let's conclude this webinar with a quick discussion on how to assess it. Students can be assessed informally during this process just by asking questions as you circulate. But some teachers want a more formal rubric or checklist. This rubric can be used or adapted as a quick reference to assist with that assessment. Attend to precision. Emerging students can communicate their reasoning and solution to others. A proficient student can incorporate appropriate vocabulary and symbols in others. An exemplary student can use appropriate symbols, vocabulary, and labeling to effectively communicate and exchange ideas. It may be valuable to assess yourself as well. This rubric is a great planning tool as you design your lessons, or just use it at the end of a unit. As we become more self-aware of the environment we create, and if it is effective in implementing the math practices, we should see a direct impact on the problem-solving and perseverance of our students. As we conclude this webinar, consider planning tasks that require students to provide answers using precise, domain-specific vocabulary. Ensure that students read problems carefully and support their answers with correct labels. It's important for you to encourage students to identify when others are not addressing the question completely, as well as include assessment criteria for communication of ideas. We hope this webinar helped clarify your understanding of Mathematical Practice 6, Attend to Precision.